Hello, good morning, student. Today we are going to discuss about viscosity. We are resuming our class after a long gap of 1 week. Today we will discuss viscosity. It is another property of liquid fluid. Actually, viscosity is what it is the force of friction between different layers of a liquid. When liquid flows or fluid flows through a tube, then the different layers of liquid exerts force on each other. For example, if we have 1, 2, 3, 4, 5 layers. So the first arrow represents that the speed of the liquid is more. The second arrow, which is smaller than first one, represents the small speed or less speed. Gradually, when we move down, the size of arrow decreases. Ultimately, the size of the lowest layer will be very small, or we can say the velocity is zero. So the different layers of the liquid will exert the force on each other. If we consider the velocity of this layer is v, this layer is v plus delta v, and this layer is v minus delta v. So the lower layer will try to increase the speed of the middle one, and the upper layer will try to increase its velocity. So the layer which is in middle will get the interaction from the two different layers, and ultimately which creates the friction, and that is viscosity. The zero viscosity liquid is not possible. You can easily observe viscosity phenomenon in water when you allow water to fall and to flow on the surface of our home or floor of home. Then it will move up to certain distance and then it comes to rest. But have you observed any liquid which is fall down on the floor and it continues to move from one room to another room, or can it creep on the surface of the water? Can water is flowing, but it will go and it will stop. Have you observed or have you found any liquid which moves continuously? And that means if you allow water to fall here, and it will go with the speed of 20 meters per second from one room to another room. That is not possible. That is called zero viscosity. Zero viscosity liquid is not possible. Viscosity, it is the force between the different layers of water, and interaction force which reduces its speed. To understand that, let us consider the profile of the water. Here we have the water is flowing here like this, and when water is flowing through this, the layer which is at the top will move with great velocity, and the layer which is here will move with less velocity. So we can consider it as almost zero speed. Its velocity will be zero, almost zero velocity. Now see, it is like the modulus of rigidity, in which if you fix these two ends, suppose A and B are the two positions, and these two are fixed. Now because its velocity is zero, so this is moving here with certain velocity, BC part. So the due to velocity, the B will become B dash and C will become C dash. So this portion is V delta T, which will produce the strain in the water surface. So what will be the shear strain? X by L. This distance is X and this distance is L. Shear strain. And the rate of shear strain, rate of change, whenever we say the rate, divide by T. So X by L into del T. Now this X by del T will be velocity. So it will be V by L. This is called the rate of change of shear strain. Hence the coefficient of viscosity is given by stress upon strain rate. What is strain rate? Change in strain rate. It will become F by A upon small v by capital L. And we can calculate its dimension as well as its unit. The unit of viscosity is poise. And the unit will be what? Force. We can calculate this unit. Force means Newton upon meter square into this velocity, meter per second. Second will go here and meter per second, and L will be also here. So it will be like this. Newton into second upon meter square will be the dimension, unit of the coefficient of viscosity. It is represented with Greek word eta. How you will read this word? This is N, but it is eta. And SI unit of coefficient of viscosity, it is Poisson. It was given by Poisson. So P-O-I-S-E. Poise is the SI unit of viscosity. It is the force between the different layers of water. And we can say that the thickness of the liquid. If the glycerin, if you consider the glycerin, it is very thick. So it will come to this. Water, it will travel more distance. Honey, it will travel some distance. So why this is happening here? It is because of the viscosity. The viscosity of water is one. Even blood and oil, machine oil will move further. This is machine oil. Machine oil. It's machine oil have very high machine oil, 113. So its viscosity is very less, and but it is thicker than water. Glycerin 830. Glycerin 830. Machine oil this. Glycerin 830 millipascal. Poise. Like this. Like this we can Poisson not PA. PA stands for Pascal, is PL. So 830 for glycerin, machine oil 113, and water is 1. For water it is 1 viscosity. So that means the thickness of the liquid is very important in viscosity. Then in viscosity we have very important law that is called the Stokes law. So let us see what is that Stokes law. According to Stokes law, if we allow, and this is one cylindrical container, cylindrical pipe which is closed from one end, and a spherical ball, steel ball of radius r is allowed to fall in it. So when a steel ball of radius r is falling here, then what will happen? When a steel ball is moving here, so according to Stokes law, the force acts on it, and that force is directly proportional to eta, that force is directly proportional to r, that force is directly proportional to v, the velocity of the liquid. If we join this directly, so F is directly proportional to eta RV. To remove this proportionality sign, take one constant 6 pi eta RV. This is called the Stokes law. The force and Stokes law, the direction of the force will be upward. This force is called the viscous force. Viscous force. It is acting in upward direction. On any ball, on any steel ball, when it is allowed to fall in a liquid. Now see, when it is falling here, so it is falling in a liquid, having, so you can write few points here, that the mass of the ball, mass of spherical ball, it is m, radius r, density rho, density of the steel ball. So when we say the density of the steel ball is rho, so it will exert the downward force, and the downward force will be density of steel ball, steel ball, it is rho, and this is liquid here, so the density of the liquid, will be rho. Now you can say the sigma. So this ball is moving down, on which mg will act. What is that mg? The force of gravity. It will be mg, and so mg, the force, downward force F downward will be mg. But we know mass upon volume equal to what? Mass upon volume equal to density. And since the ball is spherical, so the volume of the ball will be 4 by 3 pi r cube. Ultimately, we can see the m will be 4 by 3 pi r cube rho. This is m. This is the m acting on the ball. So, what will be the downward force on that ball? The downward force will be mg, downward force mg, and it will be 4 by 3 pi r cube rho g. Now when ball is falling, the liquid will exert the upthrust force. In which liquid the ball is falling, that liquid will exert the upthrust force, and the upthrust will act in upward direction. And upthrust will be m dash g. Only thing is what? Who will exert the upthrust? The upthrust is exerted by the liquid, and the density of the liquid is sigma. So we can write here 4 upon 3 pi r cube sigma g. This is upthrust. Apart from upthrust, one more force is acting in that liquid, and that force is the viscous force. This one more arrow is here, and this arrow stands for the viscous force. Viscous force, and that viscous force acts. Viscous force acts due to why viscous force is acting? Because of that liquid in which the ball is falling. So the viscous force, it will be also in upward direction, and it is 6 pi eta RV according to Stokes law, that force. Now if what is net force, upward force and downward force? If this force is more and these two are less, then what will happen? The ball will move down. ऐसा ही होता है. If you are the nail is iron nail sink in water because mg is more than upthrust, but the ship is flowing or the ship floats on the surface of the water due to the more upthrust exerted by the liquid. So in this case, initially the mg is more. When ball is here, the mg is more, and gradually when steel ball moves down, as well as it moves down, the viscous force and the force of upthrust both increases. Although we can say the upthrust is constant, but the viscous force increases due to the different layers which will exert the force. So initially its velocity is more because mg is more and these two forces are less. After some time later, the viscous force also increases due to the interaction with the layer. One situation arises at which the net downward force is equal to net upward force. Net downward force will be equal to upward force. When net downward force is equal to upward force, so the total force will be what? नीचे आने वाला force और ये force दोनों बराबर हो गए, तो net force will be 0. And when net force is 0, then its acceleration, if force is 0, अब देखिए force is 0, so according to Newton's second law, m into a will be 0. M cannot be 0, so what will be 0? Acceleration. So the body will have no acceleration after some time later. And acceleration 0, it means the velocity is constant. Because acceleration equal to what? V minus d by t. If both are equal to acceleration 0. So the ball, when this ball is falling, initially its velocity is more. After some time later, it acquires a constant velocity. When both the downward forces and upward forces are equal. That velocity is called the terminal velocity. It is called the terminal velocity. And actually we are discussing here nothing but it is the terminal velocity. What is terminal velocity? The terminal velocity is the velocity which... What is terminal velocity? Terminal velocity is the velocity acquired by the stone when it falls in a viscous liquid. Let us do some mathematical calculation for the terminal velocity. Because mg is here, and what we wrote for the mg? For mg we wrote this. So first of all we write mg. This is equal to upthrust m dash g plus 6 pi eta rv. And then we can write this m will be 4 by 3 and this m dash will be sigma. So we can write 4 by 3 pi r cube rho g. This is equal to 4 by 3 pi r cube sigma g plus 6 pi eta r. That we can write. And after that we can do more calculation. When we can do more calculation for that. Just 1 minute. This you transfer here. 4 by 3 pi r cube rho minus sigma, it is equal to 6 pi eta rv. Pi cut, 1 r will cut, 2 3 are 2 so 2 r square rho minus sigma, it is equal to 3 eta r, 3 eta v, and in denominator this 3 will come and eta will come here. So 2 r square 9 eta rho minus sigma, this is equal to e. And that will be the final derivation. for the terminal velocity. 2 by 9 r square eta rho minus sigma. If you write this equation and do calculation, definitely you will get this 2. This 3 I wrote here ना, यहाँ पे मैंने 2 का टेबल पढ़ा है. 2 2s are 4, so this 2 2 3s are 6, so 6, this 3 will come here, so it will be, right now it is here because 1 r is cut, so eta 1 r will cut, we will do 2 by 9 eta rho minus sigma into g. Which g? This g. G will be there. G will be there. Why? Because this g will be there. This much only. पढ़िए थोड़ा सा. Cloud नीचे नहीं आते हैं. Cloud remains in the sky and they floats with the terminal velocity. They have certain terminal velocity. Thank you. Thank you. Thank you. This much only. Solve questions. Ask questions.